March 2025, Tropical Cyclone Alfred made landfall along the Queensland coast, bringing devastating impacts, particularly to the Gold Coast region. On the coastline, destructive storm tides combined with massive waves, some reaching heights of up to 3 or 4 stories, caused severe beach erosion. At Surfers Paradise Beach, the aftermath was dramatic. Large sections of sand were stripped away, leaving the shoreline dramatically altered. Reports indicate that millions of cubic meters of sand were lost across nearly 500 kilometers of Queensland coastline. Experts warn that full recovery could take years as natural processes slowly rebuild what the storm took in just a few hours. In this video, we'll begin the process of setting up a coastal hydrodynamic model using DelftDashboard. In this first step, we'll create the land boundary, an essential part of setting up our coastal model in DelftDashboard. We'll begin by opening Google Earth Pro. It's important to ensure that the coordinate system and units are set correctly, so everything aligns properly later on. Then continue to search for our study area, in this case Surfers Paradise Beach on the Gold Coast. So using the Add Path tool, we carefully trace the coastline to define the land-water boundary, and thus rename our place. Once the path is complete, we save it as a KML or KMZ file. Next, we convert this file into a shapefile format using an online conversion tool like My Geodata Converter. When uploading the file, make sure to select the correct coordinate system. For this project, we use WGS84 UTM Zone 56S, which is well suited for the Gold Coast region. After the conversion, we download and extract the shapefile package. So this is the shapefile that we needed. Finally, we open Delft 3D Quick Plot from Utilities. We import the shapefile. And then save it as our land boundary file, so which it will act as our land boundary in our model later. So here we have our land boundary file already, and then we open DelftDashboard to generate the base grid. We choose our model type and bathymetry source, preferable the one that is more up to date, and the coordinate system, usually UTM. For our case, our coordinate is at 56J. And here I want to zoom out our study area so we can make the grid more precisely and accurately. Now we set the grid spacing and define the depth range appropriately. Here, since our study area is only around 15 kilometers, so I set it up as follows and make sure our yellow dot, which is the X and Y origin, are by the offshore. Before we save our grid, we are encouraged to create our working directory so it is easier for us to redirect it to it later. And now we are saving our grid at our selected folder. Next, for the third step, we want to refine the grid that we just extracted earlier. So we open Delft 3D, go to the grid, and then open RGF grid. So now we are importing both the land boundary and our base grid. Make sure the grid covers the land boundary area. So let's check the grid setting and make sure 1 is by the offshore. So that is correct. And then we want to remove the unnecessary grid to save our computational time. Okay, now we want to refine the areas where higher resolution is needed, like on our focus study area and near the coast. Depends on the area where higher resolution is needed, then we increase the M and N refinement factor, while the other which are less important to observe, we just reduce or let it as it is. And then we smoothen the line for better representation. Finally, just save our refined grid for our next step. In the step 4, we want to extract the bathymetry data. So in DelftDashboard, we imported our refined computational grid, and here are the ways. Before we save our bathymetry, we alter our particulars based on the case study. And then save the file as that file. Okay, for the step 5, we want to check and fix our bathymetry. So we open the grid and depth file in QuickIn from Delft 3D. And so if the depth values are positive upward, we need to invert them so they show depth below sea level correctly. So we change the multiple value to -1, and so our model has already been inverted to the correct depth legend measurement. So here we just save the new bathymetry data. So finally, in step 6, we want to visualize the grid with a real world image. We open the quick plot under wave module and then load our grid file. Okay, press quick view and then we take note the coordinate and the difference, which are delta x and y. So here we jot down the numbers. Make sure those are in meters. Okay, after that we want to tag the lower left coordinate and upper right coordinate to locate the grid in Google Earth Pro. Now we have 2 place mark and we take a screenshot of the surface Paradise Beach. Then we import it into the quick plot. And then align it with our grid for better visualization. So just set in the data as we have in the file dependent options. And then open the plot manager and manage our layers. And that's it, we've completed part 1.